Well, it gets on top halfway through the day. That's just how life works.
I find that. Yeah.
Well, you guys are not as active as me.
Really?
Yeah, we're not all crawling around the floor like a spider, are we?
Oh, I forgot the algorithm for the 2x2.
Yeah, you gotta stay in practice.
No.
All right, let's get some math done here.
Oh, wait, I'm doing that.
You doing that?
I don't think
I don't think that counts as math.
I don't
Or
think
it's great.
your idea meets mine. Did I hit share? Yes, I did.
What if Ben doesn't want to come?
Oh,
Ben's gonna be here.
Ben
Hi.
doesn't come.
Oh, Ben, you got the highest score in the school on your math test. You beat Jack by like 8 points.
what? I did
You did.
on the so which section of the map testing?
Now, I will say this in Jack's defense. You took the math test after we started this chapter, which dealt with circles and how many circles were on the math test.
And only 8 points.
And after we did trigonometry.
And the trig part as well, too. So,
Wait,
You had
which
a
one,
little bit
sir?
I'm just saying that you had a little bit of more knowledge than the rest of the people that took the test. However, you did score the highest. Congratulations.
Wait,
but-
on which section?
And we're talking about total score.
Out of every single MWA.
What?
In the country?
No,
How is that possible? I didn't study or anything for that thing.
no one
And
studied.
when it came to the arc part where it was talking about the circles, I completely guessed randomly.
Well, so did
Because it
everyone
talked
else.
about arcs and it was before I had figured that out.
When they took the test, we were in chapter 8. We had not even started the trig portion, and literally, there were questions on the trig that they were like, I don't know what this means.
I knew what it meant.
Oh.
Why did he beat you by 8 points?
Because you already knew all the circle stuff.
I kind of claimed when we started this chapter.
Well, we were in chapter 8 when you took the test, but I'm saying we had done the trig stuff. No, at least.
Well, I had because I took it.
Oh, you did. Okay.
I had learned like half of it.
Ooh, we get to get construction.
And I still.
Yeah, I started it and I didn't know what was going on. And then
All right. Question on the homework.
Was yesterday tangent? No, yesterday was arcs and circles.
Number 9. All right.
What happened in number 9?
Number 9. You got a big circle.
I'm sure I can
You
solve
have-
this. Let's see. So 8.
You sure? All right. We got 2 chords. Center.
Maybe 18. And then 12. Oh, and C would be
A M B. A M B.
24. CD would be 24.
D N C. D N C.
No, that doesn't seem
And
right.
O in the middle. And you're told that AB is 18. So from there to there, AB is equal to 18.
What if I don't want it to equal?
And OM, all right, that's 12. And ON is 10. Yikes, that's not good.
Wait, doesn't CD equals 24?
Now here's the problem.
No.
If
Okay.
OM equals 12 and ON equals 10, we can't use that last theorem.
Okay.
So, oh, by the way, we're trying to find out what is CD. What is CD?
Well, do you know what any of the arc measurements are? Well, we have a lot of corollaries. Hold on.
We don't.
We have a lot of corollaries in the next chapter.
Well, we're not on the next chapter.
Well, I mean this chapter.
Well, we could probably use those corollaries. Let's see. So I could use corollary 2 maybe. Corollary 1 maybe.
Wow, nothing's striking me right at the top of my head.
There's no arc measurements at all for number 9.
There is no arc measurements for number
Wait a
9.
second, you can make a triangle.
I'm pretty sure that's what we're probably gonna do.
Yeah, that's what I thought of doing, but then you don't get any angle measurements, so you can't
Yeah.
actually do
And
You will get a isosceles triangle though. Does that help?
And technically, we.
Oh, it does. No, because we don't have any measurements.
You can make a right triangle. That might help.
That's what we're talking about.
you
You
I'm
can
just,
take a wild guess and pray that it's right.
Or you
What
could
is it?
make ON, like extend ON to A and extend.
We don't know if it goes there.
All right, then just extend ON.
Wait a second. I will
To the
find
end
this out.
of the,
Do you actually do
and
that?
then draw.
Yeah,
it
but,
down.
I, but we don't know if that's a straight line.
Yeah, we do.
No, we don't.
It's
I'm
10
saying
square
don't.
root
I'm
5.
saying don't extend it to ON. Just extend it
Next
towards the outside so that it is a straight line.
One more time.
Just extend it towards the outside so that it is.
Extend ON.
So that it is a straight line to the outside.
The answer is 10
We
square root
wouldn't know
5.
where it goes, whether it's over here, or through A.
Okay.
But we could. I mean,
Put it somewhere.
The answer is 10
I mean, I
root
see
5.
what I see what the answer is, but I'm trying to think this
So
one
I
through.
got 10 root 5.
Well, how?
I can't remember. I did it last night very late.
If you're doing it consists of looking at the back of the book and writing the answer, well, then yeah, I can do that too.
No, that's not what I did.
Well, I don't know how you
I
can
can't
even
remember
get
how
to
to
that
say it.
answer.
Well, I mean, one thing we know is that this piece is congruent to that piece. It doesn't.
And so DN is also congruent to NC.
So say that again.
DN is also congruent.
Yeah,
to
we
NC.
just don't know if that's. Well, I mean, we could probably conclude that DN is not the same as AM because that's 10 and that's 12. Wow, I'm stuck on this one.
Maybe the answer is infinite. Maybe there is.
Stuck on which one?
Number
AB
9.
is 18. AB is 18.
Number
See,
9.
Oh, I know how to do it.
Oh, that's the piece we missed. Okay, so 9. All right, never mind.
I was
Obviously.
gonna say.
Right triangles.
9
figure out
right
the
triangle.
angles are.
So then we can figure out what this piece is. Then we can figure out. I'm trying to find CD. So we really want is that.
Right. What we want to figure out is so we can. You can figure that out by figuring out the hypotenuse, and then you can figure out the radius, and then you can do Pythagorean theorem to find out dn.
Got it. Right. So then we could find. Okay. So this would give us the radius, and then that would equal this or that, and then from there you're good to go. Okay, that's how it's done. All right. Duh. Well, if you don't put it on your diagram. That's why we couldn't solve it without that bit of information.
I don't know how to do number.
Oh, whose question was this? Yes or no?
Yeah.
From there. Okay.
I do as well, but also I'm curious.
Do you understand it? Well, how we got to the answer finally?
Yes.
Okay.
What I'm curious is how you solved that on 550.
On what?
550 in the book. From here, I'm looking.
What are you talking
I'm
about?
looking ahead in the book at other written exercises.
All right. Well, we'll get there.
We'll get there.
We're gonna do the whole book. Nothing else?
Yeah.
All right. Here we go. 1 through 9 all. 1 is 8. 2 is 5. 3 is 9 root 2. 4 is 55. 5 is 80. 6 is 45. 7 is 24. 7?
You just figured out what one side was and didn't double it.
Oh, you didn't need to double it. Let me relook at this. All right.
No. We're supposed to find just one. Well, radius is what we're looking for. Oh, wait. A radius.
Oh, okay.
Yeah, you can see that that's 60, so that means it's an equilateral triangle.
It's an equilateral triangle, so we find one side, we found the other side.
All right.
So if AB is 24, then OA's got to be 24. 8 is 12.
Yay.
Then we just did 9, 10 root 5. 14, it was a proof.
Very small one.
Yeah.
Prove the
Yeah,
converse.
only 3 steps.
Prove that J is congruent to K. If arc JZ is congruent to arc KZ, two arcs are congruent, and therefore their chords are congruent. So the two chords are congruent, so it's isosceles, therefore it's ipso facto. There we go. That was pretty cool. Good job solving that. 17 is not a proof, and the answer is 10 root 3. How did you guys do 17 and 18 but not 9?
I didn't do all of it.
All right. Because I would think that 17 and 18 would be more challenging, but maybe
18
not.
was challenging. Because I did it
We
before
did
we did.
Hey, can you say number 2 again? I just realized I didn't hear you.
Which one?
2.
2 is 5,
Oh,
and 18 is 32. 32. We did 18 in class?
Yeah.
But I did it before that, so it doesn't technically count.
Oh yeah, we did do that in class. I remember that, because what was the little tiny piece? Yeah, I remember that.
We didn't even have to figure out the thing.
Well, we thought we might have had, I think that's how maybe I was the one that said, hey, let's look at the tiny piece. But then we figured out, just need the radius. All right, that was it. What are we doing today?
Math.
And inscribed angles.
No,
Inscribed angles.
no,
Inscribed angles.
no, that's tomorrow.
Inscribed
Angles that are in. Aren't
We're
we
doing
doing?
We're doing a review. Ben, look on
We're doing
team.
review. I
We
was
are
just
doing
about to say
review.
that. Dang you.
That's cheating me out of it.
Well, tomorrow.
Well,
And-
if you pay attention to the calendar.
Yeah, Jack, pay attention.
Now.
And by the way, we have already proved the inscribed angles from that table from yesterday's homework, when we saw that looked like the inscribed angle was what, double or half? It looked like it was half. So we've actually done the proof. That very last column where they gave us X and we showed it was 2X,
Yeah.
that's actually the proof of it.
Wait, I hear rumbling.
I feel rumbling beneath me. There must be some large machinery moving around. Right
What
now.
does that mean? That
I mean, probably.
They're probably working on
You guys are having construction done to the building, aren't you?
Affirmative. So you have a classroom next year.
what if I don't want a new classroom?
Well, then you're going to be in the parking lot and we'll just yell at you.
I hate eighth
Stick
grade.
with the 7th grade.
There will be nothing but upper school upstairs next year. No lower school.
Finally.
All right. What do I want to do? This is what I want to do.
I draw scary snakes. You have to do it.
You do.
If I get the homework done super fast, does that mean I
You
get
should
the-
get it done super fast because
And that's not a tangent.
that's why that statement's there, because clearly it doesn't look like a tangent, but they're going to claim it is.
You look scary.
All right. So I've broken it down into sections. Each section will be on the quiz. Sometimes I believe it's 10 total questions on the quiz. Each section will have 1 or 2 questions on it. All right, McKinley, as always, you're up first.
Oh,
Pick
okay.
one. 1, 2, 3, 4. I got to share this with Ben, or did I share it with you, Ben?
Yes.
Let's
Okay.
with one.
Number 1. There's a lot of stuff going on there.
2x minus 8 equals x plus 3.
Oh, well done, sir.
Yes.
All right.
I did it.
Of course, you got to solve that.
Well, I will solve that later, but for now, I am actually
You did get number 1, at least set up correct.
x minus 8 equals 2 plus 8.
What are you talking about?
Equals x. There, I solved x.
10 equals X. No.
What? How am I? That's
8 plus 3 is 11,
11.
not 10.
Oh, I put 3. Sorry. I
So,
put 2, not 3.
11. All right. So yes, that 7.8 there is just extra information. That chord there is extra information. That second radius, extra information. You have 2 tangents that come from the same point. Then they are equal to each other. All right. That was, I forget what theorem was that. Corollary 1? Is that theorem 9(1), something like that? Is that right?
It's a math term.
All right. That was 1, 2, 3, 4. All right, Jack, you're up. 5. What? 5 through something? 5 through
I will return to you.
the next section. 5 through.
5 through 8.
Okay, 5 through 8. Pick one.
5.
Number 5.
I've already done it.
It says determine if AB is a tangent. Well, how are we going to do that? Go ahead.
Well, basically, you just got to figure out that it's the right triangle.
If it's a tangent, then it must form a right angle. Where is my drawing tool?
Literally, it does.
No, it doesn't.
Yes, it does.
Do the
Looks
math.
like it.
Ben, I haven't shared this with you.
No, you haven't. I'm staring at a blank screen.
I know, and when I asked you,
Thank
did I
you.
share it with you? You said yes.
Oh, I thought
right.
you meant something else. I thought you meant
Oh,
did you share the
Oh, I
thing on Teams, the document
Yeah.
on Teams. That's what I thought.
Okay. So Jack said that if this is true, then this, if it's a tangent, must be a right angle. Therefore, we have a right triangle.
We could do 4
but you have to confirm it's an actual right triangle. So Pythagorean theorem. And if you're going to screw this up, you're going to screw this up because you're going to not put the hypotenuse in the right spot. Remember, the hypotenuse is opposite the right angle. So is 7 squared equal to the sum of 4.5 and 5.6 squared? Yes, no, maybe? Well, is it yes, no? It is no. And I guess maybe you can get a sense for that. If you square 4.5, you get a decimal answer. If you square 5.6, you get a decimal answer. So it's just, could you get to a whole number from that? 5 squared ends in a 5. 6 squared ends in a 6. 5 plus 6 is 11. So you don't get to a whole number. So that one's a no.
Wait, hold on. This is a Pythagorean triple. You didn't tell us about this.
Which one?
Oh.
Jack did something wrong. Oh, I get it right.
All right.
I did it right. I just didn't simplify.
All right. Questions on 5 through, is it 9? 5 through 8? Questions? McKinley, you got this?
Yeah, I got it.
There will be one of these on the quiz.
Yes, only one. One thing I will.
So all you have to do is confirm that. Now, like I said, you can still screw this up. Look at number 6. There's one extra step on number 6. What's the extra step? Do what?
Well, adding.
You got to add those 2 pieces of the hypotenuse there. All right. Or potential it may not be a hypotenuse. But. All right. Yeah, 7 is a Pythagorean triple, so that's easy. All right. Now, this is a computer program that you're looking at that makes this worksheet. So I don't necessarily agree with the way they wrote this question, but I will explain it. You ready? Number 9. All right. So McKinley, you ready?
Yes,
Number 9. It says the major arc for angle 3. Well, angle 3 is right here. That's a central angle. There's no major arc there. Angle 3 would be arc NL. Do you see that?
You gotta add M. No, it's NM.
So what they're saying is, well, great. Even though that angle 3 is a minor arc, if you exclude this minor arc from the whole circle, you're left with this arc. And that one is a major arc. So I don't agree with the way it's necessarily worded, but well, I can't change the computer program. That's how they did it. So what they're really asking you to do there, and they'll have either the word major arc or they'll have nothing. So if it's a minor arc, they don't put, I wish they would. They won't put minor arc. They'll just say, name the arc for angle 3. McKinley, what's the arc for angle 3? And what's the major arc? Really? That's weird. On everyone's? Oh, you got the bonus one here. Take this.
I've already written all my answers.
Maybe you got an extra page.
I still have 4. I still have 3 and 4.
Are they numbered?
Yeah, they're numbered.
That's weird.
Well, looks like Jack is an extra buddy.
Okay. Now, no joke, because you could get confused on this, even though you understand the difference between the major and the minor arc. Are we good on those questions, 9 through whatever?
Yes, I completed them
Yeah.
all.
Ben, we good on 9 through 12?
Yes.
All right.
16.
Well, the other ones they're going to give you, instead of giving you the angle, they're going to give you the arc. So notice on question number 13, they don't give you the central angle, they give you the arc. So they give you WTV. You want to know how you screw this up? You go the wrong direction. Watch this. If I go WTV, I made a 360, right? Which is possibility, you know, if it was if I say WUW, that would be 360 degree, but it says WT. So after W, T needs to be the next thing before you get to the last letter. So what's that central angle?
Oh, that's a 2.
Okay, and it really is the complement of 2 or some other word that would describe the reflex of 2. In other words, the outside of 2. But I got to stick with the way the computer wrote that one. Hopefully that doesn't mess you up or it's too confusing. Good on that one, everybody?
Yeah.
Okay, which brings us to
MJ.
number 17. All right, who are we on? Allie? What do you think?
I know code.
For me, I would draw the arc first, JLI. So I need that arc right there. So clearly it's bigger, it's almost 360, right? All right, how are we gonna figure that sucker out? Period 2 did very well on this one. It took them a minute or two, but they figured it out.
A lot of ways you could do it.
Probably.
Well, first of all, you need to figure out what the measurement of the angle for arc, either LK or HI.
Why either one? No, you said
Oh,
either one, and I'm asking why either one.
oh, because they're both, because there's two diameters, 125. Because HK and LI are both diameters, and so, 125 is on either side.
That's not what I was thinking, but I mean, there's nothing wrong with what you said. But you made it sound like we could figure out either HI or LK or both. Which one is it? Either or both? You were right the first time. It's either. You want to know why? Why they're the same? Sometimes you stare at a picture, you don't get it, and then, you know what I mean? You can stare at it a long time and it's a silly answer, right? Yeah, you could do both, but they're really vertical. So if we find one, we found the other one. Okay, well, how are we going to find one of them? Yeah, because they're linear pair, right? They make a straight line. Okay. 180 minus 125 is how much? 55.
So then you would add 125, 55, 55, and 8.
There you go. Anybody do it?
Yep.
What do we got?
318
No,
for 7.
And then you
better not
add
be,
the-
because I think that's what the one I did in class, and it was not 318.
Yeah, it is. 17.
I thought
well,
it.
that's not the answer.
That's what the distance is.
Do it. Grab your calculator. Do it again.
I found the measure of the arc. It was central. Yeah.
Maybe I didn't do 17. Maybe I did another one. I just remember there was one answer and it wasn't 318. It
You're
was
talking about 18. 18 is 310.
okay. We did 18 then. All right.
I'm right.
I withdraw my objection.
I'm a hacker. Right then.
Hey, hacker boy,
Yeah.
it's
Yeah.
annoying. 318. You're correct. All right. McKinley.
Yeah.
Pick one. 17 through what? 24, and don't pick 18.
Okay. 20. No, wait. 21.
All right. Do it.
Okay. So
What did I recommend as your first step?
you draw out the.
Yeah, draw out SVQ. SVQ. Where the heck is V? SVQ.
And I'm trying to find the arc of that.
Well, just here's the cool thing. What do you know about arcs and central angles?
They're congruent.
They're the same. So either one's fine.
120,
Where'd you get that from?
60, if they're both sides, and 6 plus 60 equals 120.
Where do you see 60 and 60?
I assume RQ would be 60 because it's.
What do you mean? Okay, RQ is not 60.
But it should be. Okay.
It's on your paper too. RQ is not 60. Look at the diagram. Arcs are equal to central angles.
Yes.
So what is RQ? Look at its central angle.
It's at 79.
Oh, it's 79. Therefore, it's not 60 and 60, it's
60 and 79.
60 and 79,
Which would equal something.
which would equal 624. Is that right?
Probably. Right.
It would not be 624.
Yeah. 7.
You can't do that in your head, McKinley? 6 and 7.
Oh, it's 13.
0 and 9.
9.
So therefore, the answer is
139.
there you go.
Yeah, I did that one right. Oh, I didn't need any help.
Ben, any questions?
No.
Okay. Which brings us to the most interesting ones. starting with 25 through what I give you, 34 or something like that.
They're fun. They're fun. Oh, which one is 5.1?
I'm sorry.
Which one is 5.1?
Good question. Well, I'm not saying that you should ever look at a diagram and make decisions on that,
I got it.
right? Now, I would like to do every one of these, 25 to 34 in class, as many as we can do before the bell rings. So, Anna, you're up. Find what x is equal to. What are your thoughts? Why would you do that? There you go. Yes, very good. Radius, 25. So whatever 6.5 and 5.1 are, that's what, 11.6? Is that right? You don't. You just need to add 6.5 and 5.1. No triangles needed for that one. All right. McKinley, you're up. 26.
10.9 + 5.6.
Okay, that was easy. 27, Jack.
27. 4.8 + 6.8.
All right, and now it's getting tiresome.
10.6.
All right, 28.
11.6.
Anna. Allie, sorry. Oh, finally a different one. Thank God.
Is it saying 29.8?
Yeah, it's saying it's the diameter.
So then you have to divide 29.
Okay, so we're going to take half of the diameter. That would give us a radius. Half of 29.8 is what, 14.9? Is that right? So 14.9 is the radius. Okay.
So then it'd be 14.9.
I had some people solve it that way.
Or
What did it just be 14.9
minus 6.1.
And I didn't even see the Pythagorean theorem.
Minus 6.1.
Right. But your method would work, right? So if half of it is 14.9, that would be the hypotenuse. And well, if this side is 12, then this side is 12. And you could use the Pythagorean theorem to get that. Or, say it again, Jack.
You can just do minus 6.1.
Yeah, because this piece is 6.1, and that's a radius as well. So 14.9 minus 6. So there's two different ways of solving that same one. All right. Anna, you're 29. Well, you got to have two numbers to do Pythagorean theorem. I only got one.
Well, the other side is 9.8.
Right. Remember, if it's this construction, if it's a radius, diameter, if there's something going towards the outside and makes a perpendicular angle with a chord, then it cuts that chord in half. Therefore, this side is 9.1. I think this is the only way this one can be solved. Yeah. Well, I don't think that it could be solved another way than that.
I mean, there's always
Well, maybe, but I don't see it.
another way. I mean, you can always use calculus to figure out the
No, calculus wouldn't work in this. Calculus doesn't do something like this.
you could draw another line.
Well, I mean, we could make that 11. All right. Could that help us?
And I can do that and use the geometric mean.
Oh. So that would be equal to the square root of that times that. But yeah, but then we're using the fact that's 9.1.
And then that's just 9.1.
Right.
X is just 9.1.
Right. Is that true though?
No.
No.
Why is that not true?
Because remember, the geometric mean can only be used if that's a right triangle. If this is 90.
Oh, okay.
Right.
Well,
But-
then you could draw an altitude. I mean, there's always
All right,
another
so I have a new x, except we'll call it a y. Now you might be able to say something. Okay, now I can't say anything now. Yeah, I think the easiest way is the way that who are we on? Anna? So Anna or Al? Who would do that? Anna. Okay. Allie said or Anna said the right way. All right, 29's done. All right, Ben, you want one?
No, not really.
All right, McKinley, number 30.
10.5 squared. I mean, minus.
So basically the Pythagorean theorem, right?
Yes, just in reverse.
All right, is there another way for this one?
Probably.
I don't think so. I think this is straight up Pythagorean theorem. Okay. Pythagorean theorem for 30. Oh, we're just tearing through these. Jack, 31.
31 is 11.1.
Yeah, but how?
Pythagorean theorem. Draw one
On
line-
what?
Draw one line right there, and then you can use that.
What do you mean there?
From the center of the circle to the point where the intersection of the line 16.5 is.
Okay. So from here to there. Okay, now we got a right triangle.
Now that's 17.8.
How do you know it's 17.8?
Because it's the radius.
Because it's a radius. And it's 17. I have a person that's online from period 2 that was asking me to show her how to do this one. So I'm going to ask her to watch this video. That's why I need you to explain it slowly so that she can understand this. Okay, so we got a radius. Now what?
Now since we have a radius, we can use the Pythagorean theorem on that right triangle.
Okay, and opposite the right angle is side C. So give me the setup.
So you just do 16.5 squared plus x squared.
Oh my God, you talk fast.
I can talk way faster.
Yeah, but I can't write with my finger any faster. 16.5 squared plus,
Plus x.
well, we can't use x because x is right here.
Oh, well, y squared.
So we'll call that y. So plus y squared equals,
17.8 squared.
okay. Now you got to grab your calculator. We got to finish this.
It's
You get
6.7.
Yeah, but I'm saying you got to the whole thing.
Now you do 17.8 minus 6.7, and which you get 11.8.
Yeah, but I need the numbers
Why?
because I'm giving her the full explanation.
Oh, 16.
Grab your calculators. Stop the
Why do
whining.
I have to do it? All
And
right,
if you do this for me, I'll show you a trick.
all right, 17.8 squared.
Yep.
Whatever that equals.
Yes, that's what I want. It's less than 400. How about that?
Yeah.
It's bigger than 225, less than 400.
It's 316.84 or just 9.
316 point.
9.
All right.
And then the other one
Bigger than 225.
equals 272.6. That's rounded.
272.6. Okay. And then we're going to do what to both sides?
Subtract the two,
What do you get?
You get, what's the number? You get 44.59 or 45.
No. Don't round that much till the very end. 44.59.
59.
And then we have to,
Have to square root it,
okay.
which gets you 6.67.
So therefore y is equal to 6.7. Now, is that what matches the answer in the back?
The back, that's not the answer. Is it? Let me see.
Oh yeah, that's just what y is. Duh.
This is what Y is.
All right, so that's what, Jenna, that's just what y is right here. So now to find out what x is, notice that this line right here is a radius. And we've already determined that a radius is 17.8. So we're going to do 17.8 because that's the length of a radius minus this y piece that we just found that will give us x. So minus 6.7 gives us,
11 points.
and is 11.1 what's in the back?
Yes.
There you go, Jenna.
That's painful.
Well, I mean, okay, so there's a lot of work there. All right. So, Jen, if you have any more questions, send me another chat and I'll help you with it. But that's 31. All right, for you guys, I promised you a trick. All right. When you're doing the Pythagorean theorem, what's the most painful thing?
Square root.
Okay, here's the trick. I'm not going to explain why this works, Jack. You're going to like this. I'm not going to explain why this works. It's an algebra 2 pre-calc thing. I'm just going to give it to you now. You can use it. So when you're doing the Pythagorean theorem, eventually you get to something that you need to take the square root of, but your calculator wants you to hit the square root. It doesn't want you to take the answer and then hit a square root button. It wants you to hit the square root button and hit the answer. Well, there's two ways of doing it. You can hit second, square root, arrow up to that number, hit enter twice, and you get the answer. That's a lot of button clicking. Here's the easier way of doing it. So you do all your math, you get to 44.59, type that in your calculator. 44.59. And you don't. You would love for you to be able to give me the square root right now. So here's how that's done. Caret 0.5.
Eric, where's
Yeah,
the
I
carrot?
did know that.
Caret
I
0.5.
did know that. If you do anything to the 1/2 power, I've done that on my calculator.
Where the heck is the carrot button at?
It's the arrow.
The up arrow?
Yeah, it's under.
Not the up arrow. It's this
Under
thing.
clear. Under clear.
Oh, it's under clear. There it is.
Just hit caret 0.5 enter. And that gives you the square root. Now, there's math behind that. You just haven't learned that math behind it.
Oh, okay. Now I know.
And now you can take the square root without having to, oh man, I gotta hit second, square root, What was the number I was trying to type in? You know, it's saying the button sometimes. I never hit the square root button. I always just hit caret key 0.5.
Why is that a carrot? That looks more like a,
I don't know. I didn't name it.
it looks nothing like a.
It's pretty interesting math of why that is, but you get that in algebra 2. I won't steal all of Miss Newburn's fun. All right. That's 31. We're on who?
Me.
No, we're on Allie.
So you have to make a triangle.
Oh, this is the same as the previous one, yes?
Oh, I'm done. I finished before you.
So we make a triangle
Probably because of that
And then
horribly
so
long question.
that line.
is 21.7. It's done exactly the same way as the other one.
So the answer is
Okay, cool.
I will.
2 left. All right, Anna, this one's different.
well, you could do the
Heck yeah, that would be the easiest way. Pythagorean theorem, that would give us, I don't know if you want to call it y, but that would give us this side right here. And then,
So it'd be 18.7.
yeah, no, I'm just saying after, okay, we're agreeing that we could do the Pythagorean theorem to find y, and then
You would take 18.7.
subtract whatever y is from 18.7. Okay, that'll work. And last but not least, we end on McKinley, who we started with.
Okay, that was a very big question because that could be the diameter of 17.8.
Yeah, it's
But you-
not the
I
diameter.
figured that out when I drew the radius, and I was like, wait.
If this x wasn't here, then I would say maybe it is, but since the x is here, 17.8 is the distance between the right angle and the edge of the circle.
It is?
It's got to be.
Why can't you just do the radius?
You are correct.
So I saw
You
this
are
way
correct.
as using it as a radius.
And the only reason why I'm saying this is even though you're never supposed to look at a diagram and say by scale, if this is 14, then the whole thing can't be 17.
Yeah.
So yeah, this is a radius. 17.8 is a radius.
That's a point.
I'll give you a point for that. That's good.
Yes.
All right, so McKinley, you all know this? 17.8 is the radius.
Uh-huh. And that means that X should be the other side of the
True. So this radius right here is made up of this piece. Let's call it y. So if we could figure out y, then how could you figure out x?
You can make a triangle.
No. If you figure out y, let's say y is 10, how big is x?
Actually, it is.
Did I just really pull that out of my butt? All right.
It's actually 10.3.
Well, close. Okay. So if y is 10, McKinley, how do we figure out x? No.
No, it's a-
Look at the picture.
Oh, the X is, you minus 10
From,
from 14.4?
is that the radius?
No, that's not the radius. 17.
17.8. Okay. So that's what we'll do after we find y. Now we got to find y now.
All right, that's just,
Pythagorean theorem.
for,
Pythagorean theorem.
The one thing they didn't have is,
That's a radius.
I'll give you a hint. Start here.
make a triangle, I guess,
Where?
to that point to the edge of that 14 line.
And since you just made a radius, how long is it?
Oh, it's 17.8.
And how many sides now do you have of that right triangle?
Enough.
Enough to calculate y.
And
Remember, you have to have 2. Unless it's a special right triangle, then you just need 1.
so 17.8 squared.
Minus,
I know it's the 4 thing. That.
and when you get the final answer, do it caret key 0.5, entered.
It's 10.46 or 10.5.
Therefore, how long is x?
You actually press more numbers by doing caret key 0.5 instead of second square. Or
No, not true.
second square root. 1, 2 buttons.
Yeah, but then you got to put the number in.
3.9.
Yeah, just do. Yeah, that's why you gotta hit 1, 2, and then you gotta press a button.
No, you have to put the number in.
How the heck did I get that
You have to
wrong?
press like 6 buttons for.
Okay,
There you go.
Jack,
You have to press
Jack. 44.59. Let's take the square root. Now, count keystrokes. Second, I'm sorry, blue button, square root,
And then I gotta
4.59, or arrow, how many arrows
Oh, I
up?
did that with the wrong answer.
1, 2. Oh, well, I don't do. Or you could
See
just
what I'm
do.
saying?
Or you could just do second answer.
Yeah.
Okay, that's still 2.
So then, so
That's still second. 1,
So-
2.
3, 4, 5, 6, 7. All right. Now, if you do
Caret key 0.53.
44 point,
It's 3.
what do you?
Caret key 0.5 is 3 buttons.
No, it's not, because you still have to enter in the button.
4 with the enter, but that, you also have an enter with the other one.
But you still,
You still have to
type
enter in the number.
No, you don't.
Well, that depends on whether or not.
No,
have
you
it as your
don't.
Last thing. No, false.
You
That's-
still have to hit
that only
answer in
depends
order
on-
to get that.
That only depends on if you got 44.
No, I'm saying this is the starting point. We're at 44.59. It's on your screen.
Well, then why don't I just, if it's already on my screen, then I'll just go back and then put a square root symbol.
How many keystrokes?
1, 2, 3, 4.
1,
5.
2, 3, 4, 5. Insert. Right? That's 1, 2, 3, 4, 5. Insert is 6. Second is 7.
Okay, but-
Square root is 8.
From the beginning.
3.
From the beginning.
3.
From the beginning, using the square root symbol is the exact
You-
as
I'm
actually
gonna take your
less.
point away.
No. No, from the beginning, it's less. If you're just starting out with
Are
nothing.
you seriously going to argue that 8 is smaller than 3?
No, well, actually, technically it could be, but I'm just gonna say that if you have just nothing at the beginning, you still.
That's not what, that wasn't my premise. My premise was you start with 44.59 on the screen and you got to take the square root. If you start from the beginning, now, Jack, this is what I will say about what you're saying. If you're really thinking ahead, what should you really do with the problem?
Just do it first and then. Just do
What do you mean do it first?
Just figure out, just type in 44.59.
No.
What do you, if I'm really thinking ahead.
If you're really thinking ahead, you really want to save yourself some time, and it will save you 1 keystroke if you do this, what should you type?
Just,
You should type second from the very start,
yeah,
square root,
yeah.
and then whatever it is, let's just say it was c squared minus b squared. That's what you should type.
Yeah.
That will be the fewest keystrokes right there. But you'll need to take the square root of the cube root a lot of times, and I always find that cube root would be what?
Wait, it's not c squared minus b squared, it's a squared minus, it's a squared plus b squared. Oh,
No, c squared.
it is c squared plus b minus.
Now it could be a squared plus b squared too,
Oh, okay.
but I'm just giving one example. Because you get to college and I mean, you take a math class, calculus class, you're going to be typing on that calculator furiously, and you start to, learn little tricks that just save yourself a little bit of time. All right, the quiz. All I'm going to do is take 1 question or 2 questions from each one of these sections. That's the quiz. It's 10 questions tomorrow, and then we'll do inscribed angles, all 3 flavors. There are 3 flavors of inscribed angles.
Oh, I know them.
No, you don't.
Yes, I do.
Did you read ahead?
Yes.
Okay, then you do know. All right. All right, Ben, any questions?
Nope.
I will have the quiz up by early morning. So if you want to take it early morning, if you're bored or something, you can.
Okay.
All right, any questions, anything we did?
Nope.
All right, catch you later.
All right. Goodbye. Have a nice day.
You as well.